So I'm Anna Vissens, head of data science at The Guardian, and I'm going to talk about the project that we did together with Journalism AI. We are friends with Journalism AI, and we did a couple of projects in the past with them, but also collaborated on some other initiatives by Polis. It's a think tank at London School of Economics and Political Science. So for this particular project, we teamed up with Follow the Money and the Daily Maverick. Why we did that? Because all three publishers work a lot with investigative journalism, and we thought that it would be interesting to see if we can help our journalists find clues, person of interest, as we tell them, as we call them, and also trying to make connections. This is super important when we suspect that something wrong is going on. So basically, that was our dream mission. We wanted to build an AI system that should be able to disambiguate entities, and by entities in this particular project, I mean names. We also wanted to auto-generate graphs of the relationships between different entities in our data sets, but we also wanted to build a generic enough tool that different newsrooms can use and can apply to different data sets. So basically making uncovering bad actors quicker and easier. So one of the challenges when we work with unstructured data, such as text, is to understand context. So imagine that you are typing in a search engine the word Java. So if you do not add any context to this, the search engine won't be able to understand if you are talking about the coding language, or coffee, or the island. So basically, the same happens when we are trying to disambiguate different people who share the same name. So there is an answer to this problem, and it's called entity linking. Entity linking is considered to be the backbone of any search engine. So in this project, we decided to try the same approach and see if we can use the same way with our solution. So this is a very high-level pipeline that we built during the project. So the aim of the project was to build the entity linker. So this is the gray box on this diagram. So basically the model which will be able to look at names we mentioned in our data set and match them to the right profile in our knowledge base. So by the knowledge base, you can think about this knowledge base as a huge lookup table where you put a lot of names with different profiles and IDs. So that means that if you have two different people who share the same name, you will have two records. So the same name, but different profile and different ID. So actually, at this point, we needed to make a couple of crucial decisions. And I have to say that some of them backfired on us at a later stage, and I will explain why. So it would be much more insightful if we could use a real data set, so for example, from previous data leaks, etc. But we had a limited amount of time to work on this project, only 6 months, but actually only 10% of our time we dedicated to this project. So when we started looking at different data sets that we could use, we quite quickly understood that it would be just super challenging to get the right data in the right format. So one decision that we made for this proof of concept, we decided to use Guardian articles. So we collected around 300,000 articles. And we thought that, well, it's a good data set, it's clean, ready to use, but also we thought that we would have lots of names to actually look in our knowledge base, because we cover lots of, we mention lots of different people in our articles. So the next step that we needed to do is basically extract names from our articles. How we did that? We used a very well-known approach. We call it named entity recognition. I'm pretty sure that some of you tried maybe these models before, but for those who haven't, I will explain very quickly. So basically, these models are pre-trained to identify different entities in text and classify them into kind of predefined categories. So this is a very simple example when the model identified some personal names, names of some organizations, or like cities, countries, etc. So you can find these models online. They are open source. So we used models created by Spacey or Explosion AI. So the next step was to build a knowledge base, the one that I mentioned on the previous slide. So we had two options. One option would be to go and use Wikidata. And actually, in many projects like this, people usually use Wikidata because it's a very nice data set, clean, and you can find a lot of names there. But because we made a decision to use Guardian articles, we decided to be a little bit more adventurous with our database. And we downloaded two databases we found online, one by Little Sis and another one Open Sanctions. So both of these data sets contained persons of interest, so-called. But we soon regretted, actually, this decision because we just very quickly realized that it was very challenging to work with these data sets. First of all, they didn't have any affiliation between them, and we had two different schemas, very different schemas. So before merging all this data, we needed to clean a lot and basically to understand how we can specifically tackle duplicates. But then we had quality issues. There were very empty entries. Some descriptions just scraped from LinkedIn, for example. But the main problem was that we still had some duplicates. So basically, same people, but with different IDs and different description. Okay, nevertheless, we got to the point when we were about to train our model. But to train the model, it's a supervision kind of task. So to train a model, we needed to show the model a lot of examples with a snippet from our data set, with a name mentioned there, and actually the right profile from our knowledge base. And if you show the model enough examples like this, it will learn the pattern. But with any natural language processing projects that we do, especially when you need to annotate any source of data, we start with writing a very clear and concise annotation guide. So we spent some time together annotating some examples, and we also drew kind of this decision tree. It's an my artistic representation of the decision tree from our guide. But basically, you can see that first we needed to do 3 binary decisions. And these 3 binary decisions addressed the quality issues that we had in our data. So first of all, our named entity recognition model could fail, and it happens. Sometimes it recognizes an organization as a personal name. Then we had some some snippets that didn't contain enough context for an annotator to make a decision. And then sometimes we just couldn't find right candidates in our knowledge base. But when you are through this, then you could choose the right name from a list of up to 10, I think we used. So this is how the annotation process looked like. This is the tool called Prodigy by the same actually developers behind Spacey models. It's not a free tool. You need a license, but I can tell you it's not expensive, and it's really, kind of worth any penny that you pay for it. So you could see that we surfaced one paragraph with a name highlighted there, and then the annotator could choose some options. So we had 9 annotators. We spent 40 hours altogether, and we produced around 4,000 examples for the model to actually learn. So we trained an entity linker, and we observed the accuracy around 70%. It's actually a good number, especially when you're talking about a very complex task like this and only 4,000 examples. Usually you need more. But, and this is a big but, quite soon we realized that our training data set actually didn't contain enough examples of multiple candidates who share the same name. So for example, when we were talking about Barack Obama, it was always Barack Obama, the American president. Or we didn't have enough mentions of single names to teach the model to disambiguate a little bit better. So when we were talking about Obama, we usually were talking about Barack Obama and not even Michelle Obama, right? So we also, because we decided to use Guardian articles, we had a little bit of a bias in our data set because we had lots of candidates share the same context, basically. We had a lot of politicians, and all these things made our model a little bit weaker and also not like, that great to generalize. So these are the main lessons we learned during the project. First of all, as I mentioned, it's actually quite challenging to build a model which is generic enough to be applied by different newsrooms to different data sets. So I had this gut feeling that we probably needed to go through this process again, again, and again. Every time when you have a new data set, you have to train a new model. And then the quality of your data is absolutely paramount. And I'm talking about both, your knowledge base and also the data that you want to analyze. And this is my kind of personal hint in terms of annotation guides, because my colleagues at The Guardian know that I have, I pay a lot of attention writing these guides, because in the end, the quality of your annotations will translate to the quality of your model. So this is super important. And also you have to understand that you need actually to invest a lot of time in the process. It's a time-consuming task, especially when you need to annotate manually a lot of examples. So the last thing that I wanted to mention, because obviously a lot of things have changed since then. We are living through an LLM revolution right now. So when we started working with large language models at The Guardian, I actually thought that it would be very interesting to actually revisit the project and trying to understand if we can leverage the power of these models to enhance our entity linker. And indeed, a couple of months ago, I spotted a research paper in Archive talking exactly about that. So basically, these researchers, they try to augment the context that we gather, in your knowledge base, for example, with LLMs, and also creating some additional descriptive information. So you can use this augmented data to train a new entity linker. So they claim that the LLM augmented entity linker performed actually much better than the standard one. And I can, to be honest, understand why. So tomorrow we are going to have a workshop and using this example, this particular project to understand how we can work with these models and how we can apply AI for very complex problems like this one.